Imagine, for a moment, a star acting so bizarrely that scientists can't quite wrap their heads around it. This isn't science fiction, it's real, and it's happening right now in our own galaxy. Meet TABBY'S star, a cosmic oddity that's been flickering and dimming in ways we've never seen before. Some scientists think it might be surrounded by a colossal structure, something built by an advanced alien civilization. Others believe it's just a natural phenomenon, like a big cloud of dust. So, what's really going on? Is this the first sign of intelligent life beyond Earth, or just a stellar mystery waiting to be solved? Stick around, because we're diving into the enigma of TABBY'S star, and trust me, you won't want to miss this. Initial discovery: unusual dimming events spotted. In the vast expanse of the cosmos, astronomers are always on the lookout for the unusual. One such anomaly that has piqued their interest is the strange behavior of TABBY'S star, also known as KIC 846-2852. The story begins with the initial discovery of unusual dimming events, which were first spotted by a group of citizen scientists sifting through data from the Kepler Space Telescope. These volunteers, part of the Planet Hunters project, were tasked with identifying potential exoplanets by observing the slight dips in starlight as a planet passes in front of its host star. However, the dips in brightness observed from TABBY'S star were anything but slight. The dimming events were erratic and dramatic. Unlike the regular, periodic dimming caused by a planet orbiting a star, TABBY'S star exhibited irregular and significant drops in brightness. At times, the star's light would dip by as much as 20%, a phenomenon far too substantial to be explained by a planet. This unusual behavior sparked a wave of speculation and intrigue among astronomers. The data showed that the dimming events were not only irregular in time but also varied in depth, making it challenging to pin down a consistent pattern. This inconsistency ruled out many conventional explanations, such as a planet or a binary star system, leaving scientists scratching their heads. The initial observations were made over a period of 4 years, during which the Kepler Space Telescope continuously monitored the star. The data revealed that the dimming events were not uniform. Some dips were brief, lasting only a few days, while others persisted for much longer periods. The irregularity of these events suggested that whatever was causing the dimming was not a solid, orbiting object like a planet. Instead, it hinted at something more complex and dynamic. The star's light curve, a graph of its brightness over time, resembled a series of random, uneven dips, adding to the mystery. The discovery of these unusual dimming events was a game changer. It opened up a Pandora's box of possibilities, from natural phenomena to more exotic explanations. Astronomers began to consider a range of hypotheses, from massive clouds of dust and debris to the remnants of a shattered comet. The irregular nature of the dimming suggested that the cause was not a single, solid object but rather a collection of smaller, transient objects. This line of thinking led to the idea that the star might be surrounded by a large, irregular cloud of dust, which could explain the erratic dimming. However, this explanation was not without its challenges, as the amount of dust required to cause such significant dimming would be enormous and difficult to sustain over time. The mystery of TABBY'S star had only just begun to unfold. No periodic pattern, inconsistent with planets. One of the most puzzling aspects of TABBY'S star, also known as Boyajian star, is its irregular dimming pattern. Unlike the consistent, periodic dips in brightness caused by planets passing in front of a star, TABBY'S star exhibits erratic and unpredictable behavior. This inconsistency has led astronomers to rule out planets as the cause of its unusual light fluctuations. Planets orbit in a predictable manner, creating a regular pattern of dimming that can be easily observed and calculated. However, TABBY'S star does not follow this pattern. Its brightness can drop by as much as 22% at irregular intervals, making it difficult to attribute the dimming to any known astronomical phenomenon. The lack of a periodic pattern is a significant clue that something else is causing the dimming. Planets, for instance, would cause a star's light to dim at consistent intervals, corresponding to the planet's orbit. This regularity is a hallmark of planetary transits. For example, when a planet like Kepler 186f passes in front of its star, the dimming occurs at predictable times, allowing scientists to map out the planet's orbit. TABBY'S star, on the other hand, dims sporadically. Sometimes, the dimming lasts for days, while other times, it can persist for weeks or even months. This irregularity suggests that the cause is not a simple, orbiting object. Another intriguing aspect is the varying depth of the dimming events. Planets cause uniform dimming because they block a consistent amount of light as they pass in front of their star. In contrast, TABBY'S star's dimming events vary greatly in depth. Some dips are shallow, while others are profound. This variability is inconsistent with the behavior of planets. It's as if something is partially blocking the star's light in a non-uniform way. This could be due to a large, irregularly shaped object or a collection of smaller objects orbiting the star. The erratic nature of the dimming has led to a variety of theories, including the possibility of a megastructure or a cloud of dust. The unpredictable nature of TABBY'S star's dimming has also made it challenging to study. Astronomers typically rely on patterns to understand celestial phenomena. Without a consistent pattern, it's difficult to predict when the star will dim next or how long the event will last. This unpredictability has sparked a great deal of interest and speculation within the scientific community. Some researchers have proposed that the dimming could be caused by a swarm of comets or a large cloud of dust. Others have suggested more exotic explanations, such as the presence of an alien megastructure. While these ideas are fascinating, they remain speculative until more evidence is gathered. The lack of a periodic pattern is a significant hurdle in understanding the true nature of TABBY'S star. Megastructure hypothesis, Dyson swarm concept. TABBY'S star, also known as KIC 846-2852, has puzzled astronomers with its erratic dimming patterns. One of the more intriguing explanations for this behavior is the megastructure hypothesis, which suggests that the unusual light fluctuations could be caused by an artificial structure built by an advanced civilization. Central to this idea is the Dyson swarm concept, a theoretical construct proposed by physicist Freeman Dyson. A Dyson swarm is a collection of solar power satellites or habitats built around a star to capture its energy. The idea is that an advanced civilization might construct such a swarm to meet its energy needs, which would grow exponentially as the civilization develops. These structures would orbit the star at varying distances, creating a complex network that could explain the irregular dimming observed in TABBY'S star. The swarm would not form a solid shell but rather a loose collection of objects, allowing for the uneven light patterns seen. The concept of a Dyson swarm is rooted in the laws of physics and engineering. To harness the energy of a star, a civilization would need to build structures that could capture and transmit this energy efficiently. Solar panels or other energy-capturing devices would be arranged in a swarm, with each component contributing to the overall energy collection. This swarm would be dynamic, with components moving in and out of the line of sight from Earth, causing the irregular dimming patterns. The idea is not just science fiction. It is a plausible scenario based on our understanding of physics and the potential needs of advanced civilizations. Critics argue that the Dyson swarm hypothesis is speculative and that natural explanations, such as dust or debris, are more likely. However, the irregular and dramatic dimming of TABBY'S star has not been fully explained by natural causes alone. The Dyson swarm concept remains a fascinating possibility, driving further research and debate. It challenges our understanding of what might exist beyond our solar system and pushes the boundaries of our imagination. Whether or not a Dyson swarm exists around TABBY'S star, the idea itself is a testament to human curiosity and our quest to understand the universe. Comet swarm theory, natural explanation attempts. TABBY'S star, also known as Boyajian star, has puzzled astronomers with its unusual dimming patterns. One of the natural explanations proposed to understand this phenomenon is the comet swarm theory. This idea suggests that a large group of comets or comet fragments could be orbiting the star, causing the irregular dimming observed. Comets are icy bodies that release dust and gas as they approach a star, which could potentially block some of the star's light. If a swarm of these comets were to pass in front of TABBY'S star, it might create the erratic dimming patterns that have been recorded. The concept of a comet swarm is not entirely far-fetched. Our own solar system has a reservoir of comets known as the Oort cloud, a distant region filled with icy objects. Occasionally, gravitational perturbations can send these comets hurtling towards the inner solar system. A similar mechanism could be at play around TABBY'S star. The idea is that a recent gravitational disturbance, perhaps caused by a passing star or another celestial event, might have dislodged a group of comets, sending them on a trajectory that intersects with our line of sight to TABBY'S star. This would create the irregular dimming as the comets and their debris pass in front of the star. However, the comet swarm theory has its challenges. One of the main issues is the sheer amount of material required to cause the observed dimming. The star's light has been observed to drop by as much as 22%, which would require an enormous number of comets or a significant amount of dust. Additionally, the dimming patterns are highly irregular, with some events lasting for days or weeks, while others are much shorter. This variability is difficult to explain with a simple comet swarm model. Some scientists have suggested that the comets might be breaking apart as they approach the star, creating a cloud of dust and debris that could account for the longer dimming events. But this is still speculative and requires more evidence to be confirmed. Another point of contention is the lack of infrared radiation that would typically be associated with a large amount of dust. When comets release dust, this material absorbs some of the star's light and re-emits it as infrared radiation. Astronomers have searched for this signature around Tabby's star but have found very little. This could mean that the dust is not present in the quantities needed to cause the dimming, or it might be distributed in a way that makes it difficult to detect. Alternatively, the dust could be very fine and dispersed, making it less effective at blocking light and emitting infrared radiation. Despite these challenges, the comet swarm theory remains one of the more plausible natural explanations for Tabby's star's strange behavior. Further observations and studies are needed to fully understand this enigmatic phenomenon. Dust clouds, wavelength-dependent dimming evidence. Dust clouds have been a significant factor in explaining the peculiar dimming patterns observed in Tabby's star, also known as KIC 846-2852. This star exhibits irregular and dramatic drops in brightness, which have sparked various theories, including the possibility of megastructures built by an advanced civilization. However, one of the most compelling explanations involves dust clouds. The key to understanding this lies in the concept of wavelength-dependent dimming. Different types of dust particles scatter and absorb light at different wavelengths. For instance, smaller dust particles tend to scatter blue light more effectively than red light. This means that when light from Tabby's star passes through a dust cloud, the amount of dimming observed can vary depending on the wavelength of the light being measured. Astronomers have observed that the dimming of Tabby's star is more pronounced at shorter wavelengths, such as blue and ultraviolet light, compared to longer wavelengths like red and infrared light. This pattern is consistent with the presence of dust clouds. To further support this idea, researchers have conducted detailed analyses of the star's light curves. These curves show how the star's brightness changes over time. By examining the light curves at different wavelengths, scientists have found that the dimming events are not uniform across the spectrum. This wavelength-dependent dimming is a strong indicator that dust is involved. For example, during one of the dimming events, the star's brightness in the ultraviolet range dropped significantly more than in the infrared range. This kind of behavior is exactly what you would expect if dust particles were blocking the light. Moreover, the irregular nature of the dimming events adds another layer of complexity. Dust clouds are not static. They can move and change shape over time. This could explain why the dimming of Tabby's star is so unpredictable. The clouds might be clumpy or unevenly distributed, causing the star's brightness to fluctuate in a non-periodic manner. Additionally, the dust could be part of a larger debris disk or a collection of comets orbiting the star, which would further contribute to the irregular dimming patterns. Why the anomaly still isn't solved. Tabby's star, also known as Boyajian star, has puzzled astronomers since its discovery. The star exhibits unusual dimming patterns that can't be easily explained by conventional astrophysical phenomena. The anomaly remains unsolved due to several factors. First, the dimming is irregular and doesn't follow a predictable pattern. This makes it challenging to model or understand the underlying cause. Unlike typical stars that dim slightly due to orbiting planets, Tabby's star can dim by as much as 22% and doesn't follow a regular schedule. Another reason the mystery persists is the lack of direct evidence. Astronomers have observed the star's light spectrum, but it doesn't show the clear signs of dust or debris that would typically explain such dimming. Additionally, the star's behavior doesn't match any known stellar phenomena. Some have speculated about the presence of a megastructure built by an advanced civilization, but there's no evidence to support this idea. The scientific community remains skeptical of such explanations without concrete data. The star's distance from Earth also complicates the investigation. Located about 1,280 light-years away, detailed observations are challenging. Current telescopes can't resolve the star's surface or any objects orbiting it. This means astronomers must rely on indirect methods, like analyzing the star's light, to understand what's happening. New technologies and observations are needed to gather more data. Until then, the mystery of Tabby's star's unusual dimming will likely continue to baffle scientists. Observatories trying to track dips in real time. Astronomers around the world have been glued to their telescopes, trying to catch the mysterious dips in brightness of Tabby's star in real time. This is no easy task. The star, officially known as KIC 846-2852, doesn't follow the usual patterns of dimming that we see with exoplanets or other known celestial phenomena. Its dips are irregular, dramatic, and utterly baffling. To study this, observatories have had to get creative. They've set up networks of telescopes, both professional and amateur, to monitor the star constantly. When a dip starts, alerts go out, and astronomers scramble to point their telescopes at the star, collecting as much data as possible. It's like trying to catch a shadow that only appears randomly. One of the key players in this effort is the Lascumber's Observatory. They have a global network of telescopes that can observe TABBY'S star without interruption. When the star starts to dim, their system springs into action, capturing data across different wavelengths. This is crucial because the nature of the dip, how much the light decreases and at what wavelengths, can give clues about what's causing it. For instance, if the dimming is the same across all wavelengths, it might suggest something like dust or debris. But if it's different, it could hint at more complex structures. The observatory's real-time tracking has provided some of the most detailed data on these enigmatic events. Another approach involves citizen science. Projects like the American Association of Variable Star Observers, AAVSO, have enlisted amateur astronomers to help monitor TABBY'S star. These amateur astronomers, equipped with their own telescopes, provide valuable data points that complement the work of professional observatories. Their contributions are especially important because they can fill in gaps when professional telescopes aren't available. The collective effort of these amateur astronomers has been instrumental in capturing the fleeting dips in real time. Their passion and dedication have turned this into a global endeavor, showcasing the power of community-driven science. The data collected from these real-time observations is then analyzed by teams of scientists. They look for patterns, anomalies, and anything that might explain the strange behavior of TABBY'S star. The hope is that by catching these dips as they happen, they can gather more precise information. This could help rule out certain theories, like the presence of a megastructure, or support others, like the idea of a cloud of dust. The process is ongoing, and each new dip brings a new opportunity to learn more. It's a testament to human curiosity and the relentless pursuit of understanding the mysteries of the universe. What new data might finally answer the mystery? The mystery of TABBY'S star, also known as Boyajian star, has captivated astronomers and enthusiasts alike. To unravel its enigmatic behavior, scientists are eagerly awaiting new data from various sources. One promising avenue is the Transiting Exoplanet Survey Satellite, TESS, which is designed to observe the brightness of stars. TESS's high-precision measurements could provide fresh insights into the erratic dimming patterns of TABBY'S star. Unlike its predecessor, the Kepler Space Telescope, TESS offers a longer observation window, allowing for more comprehensive data collection. Ground-based observatories are also playing a crucial role. The Lascumber's Observatory, for instance, has been monitoring TABBY'S star continuously. This continuous monitoring is vital because the star's brightness can change unpredictably. By keeping a constant eye on it, astronomers can capture any sudden dips in brightness and analyze them in real time. This approach has already yielded some intriguing results, but more data is needed to form a conclusive picture. Another exciting development is the involvement of citizen scientists. Projects like the Planet Hunters Initiative have engaged the public in the search for answers. Volunteers sift through data, looking for patterns that might have been missed by automated systems. This collective effort has proven to be valuable, as human eyes can sometimes spot anomalies that algorithms overlook. The combination of professional and amateur efforts is broadening the scope of the investigation. Spectroscopic analysis is another key area of focus. By examining the light spectrum of TABBY'S star, scientists can determine the composition of the material causing the dimming. If the dimming is due to dust, the spectrum will show specific signatures. If it's due to something more exotic, like a megastructure, the spectrum might reveal unusual elements or compounds. This method provides a direct way to differentiate between natural and artificial causes. In the coming years, the James Webb Space Telescope, JWST, is expected to offer even more detailed observations. With its advanced infrared capabilities, JWST can peer through dust clouds and provide a clearer view of what's happening around TABBY'S star. This telescope could potentially detect heat signatures or other indicators that point to the presence of a megastructure. The anticipation for JWST's data is high, as it promises to shed light on one of the most perplexing astronomical mysteries of our time. Alright, let's wrap this up. So, we've been on this wild ride trying to figure out what's going on with TABBY'S star. It dims and brightens in weird ways, and scientists have been scratching their heads, tossing around ideas like megastructures built by aliens or just a bunch of dust messing with our view. The truth is, we are not entirely sure yet. But that's the exciting part, right? The mystery, the unknown. It's like we are all space detectives trying to solve this cosmic whodunit. Now, first know what you might be thinking. This is all so fascinating, but what can first do to be a part of this? Well, you can keep your eyes on the skies and your ears to the ground. Follow the latest research, maybe even support citizen science projects that let you help analyze data. Who knows? You might be the one to crack the case. And hey, if you loved this deep dive into the weird and wonderful world of Tabby's star, stick around. We've got plenty more mysteries to explore, from the far reaches of the universe to the tiniest particles that make up everything around us. So, hit that subscribe button, smash that like button, and let's keep unraveling the enigmas of the cosmos together. Until next time, keep looking up and stay curious.